Hello my dear students. Let us start from the beginning the chapter refraction. देखो मैं तुमको आगे कहूची तमे रिफ्रैक्शन चैप्टर वीडियो लिंक जेते फॉलो करिवो आगो तुम पाखरे तुम नोट्सटा रख नोट्स सहित मो वीडियो लिंक को फॉलो करो तापर मो एग्जाम करिवे एग्जाम कला परे भागे चैप्टर सरिबो तो मो स्टार्टिंग कोची पूरा गोटे क्लास ले तथापि फ्रॉम द बिगिनिंग आई एम स्टार्टिंग द चैप्टर रिफ्रैक्शन एट प्लेन सरफेस आपर पढाबो रिफ्रैक्शन एट स्फेरिकल सरफेस तापर पढाबो लेंस ये तीनटा का चैप्टर मिसिंग तुम होते रिफ्रैक्शन तो let us first start the chapter refraction. We know that light is an electromagnetic radiation. Light is an electromagnetic radiation. Light travels in a straight line with a velocity 3 into 10 to the power 8 meter per second. In a particular medium, there is no change in velocity of light. But whenever there is a change in medium, there is a change in velocity of light. So whenever a ray of light is traveling in a straight line and strikes a reflecting surface, it returns back to the same medium according to the laws of reflection. So here there is no change in velocity of light. But whenever a ray of light is incident on a transparent medium, just like water, glass, etc., light will pass through that medium with a change in the path of light. I will explain regarding this. In between the optics and electrostatics, let us compare one physical quantity. In electrostatics, you have studied about one physical quantity that is called permittivity of a medium. Similarly, in refraction, we will study about the refractive index of a medium. सेठी permittivity रो काम जहा एठी refractive index रो काम होछि permittivity of a medium रे हम कोन पढुथिले if permittivity of a medium increases or dielectric constant of a medium increases, force between 2 point charges decreases, means Coulomb force is inversely proportional to permittivity of a medium, just like that. If refractive index of a medium increases, then velocity of light in that medium decreases. जितने velocity अधिका change होपले सेते bending अधिका हो मु diagram करके बुझेगी. अर्थ if there is a change in medium, there is a change in refractive index, definitely there will be a bending of ray of light and there will be refraction. हम detail पढ़िबा. In case of permittivity, जे कोन छोटे मीडियम और permittivity बाहर करथलो एआर का तुम स्टैंडर्ड मीडियम नोथलो आ एआर रो डायरेक्टली कांस्टेंट बा रिलेटिव परमिटिविटी ता हम 1 कहथिले हालांकि समिति जेते सो मीडियम रो रिफ्रैक्टिव इंडेक्स बाहर करबा हमें बाहर करा इन कंपैरिजन टू एआर और वैक्यूम आ एआर रो बा वैक्यूम रो रिफ्रैक्टिव इंडेक्स को यूनिट बा 1 होगा ठीक अछि वर्तमान कोन कराला पूरे ट्रांसपेरेंट मीडियम a ray of light is falling on a transparent medium माने कोन गोटे ग्लास अछि ता कंटेनर रे किछ वाटर अछि एआर रो लाइट ता देखि फॉल कला का ऊपर वाटर ऊपर फॉल कला बा ग्लास ऊपर फॉल कला ता ऊपर कोन होछि देखुछि हला इट इज ऑब्जर्व्ड देयर मन दीटा मीडियम अछि दीटा रे रिफ्रैक्टिव इंडेक्स तुम दे दी रिफ्रैक्टिव इंडेक्स पछे डेफिनेशन देबे मन खाली दीटा मीडियम अछि दीटा रिफ्रैक्टिव इंडेक्स अछि गोटा कर mu1 आ गोटा कर mu2 if mu2 is greater than mu1 then first medium is called rarer medium second medium is called denser medium dita jahar refractive index अधिका हिबो that is called optically denser medium jar refractive index कम ता को optically rarer medium ठीक अछि suppose dita medium तो बिहाला water and glass हला तर water गोटे medium glass गोटे medium water refractive index to glass refractive index अधिका तो water ता को rarer medium glass को हम denser medium remember हला तो दीटा मीडियम रे जहार रिफ्रैक्टिव इंडेक्स कम थिबो ताको कहबा रेयर मीडियम जार रिफ्रैक्टिव इंडेक्स अधिका थिबो ताको डेंसर मीडियम रिमेंबर एआर और रिफ्रैक्टिव इंडेक्स सबुठु कम एआर सहित जो मीडियम थिबो एआर ता कहबो तमे रेयर मीडियम आर मीडियम ता कहबो डेंसर मीडियम ऑप्टिकली रेयर और ऑप्टिकली डेंसर ठीक अच्छे आ जिते डेनसीटी बढ़िबो सेते बेंडिंग बढ़िबो मन रख सेते वेलोसिटी ऑफ लाइट चेंज होबो किंतु हम डिटेल डिस्कशन करबो तेणु whenever a ray of light strikes a transparent medium means the medium through which light can pass. Transparent medium, then the interface which separates two media. Medium ro plural which media? It is air gotiye, glass gotiye medium. So air medium or glass medium को जोटा separate होची ता कोई interface. So whenever a ray of light strikes a glass surface or water surface or any transparent medium, there is a change in the path of light in the denser medium. Denser medium रे light रो path का change है गला. काहे change ना तो पछे कोई नहीं कोई चीज, but the change in path of light. This phenomenon is called refraction. So whenever there is a change in path of light, when light travels from one medium to other, it's called refraction. It's called refraction. What was the call? When a ray of light travels from rarer to denser medium, when a ray of light travels from rarer to denser medium, देखो, are the interface drop normal? अलग, जो medium रे, वाले मन रखो, this ray is incident ray, this ray is refracted ray, this is the normal. जो medium रे incident ray रहिबो, सेटा first medium कहिबो. जो medium रे refracted ray रहिबो, ता कहिबो second medium. इंसिडेंट रे ता नॉर्मल सहित जति एंगल करबो कत इंटरफेस गुड नॉर्मल रखा है ता कोई एंगल ऑफ इंसिडेंस रिफ्रैक्टेड रे ता नॉर्मल सहित जति एंगल करबो ता कोई एंगल ऑफ रिफ्रैक्शन ए एंगल ऑफ इंसिडेंस नै जाई एंगल ऑफ रिफ्रैक्शन दै छी आ ए पार्टटा तो मैं देखिबा दरकार नै ए पार्टटा हम पछकु बजेबी स्नेल्स लो परिसला एबे देखो when a ray of light travels from rarer to denser medium देखो प्ले जदि denser medium न था से ए पाथ रे जाइथांदा but denser medium जोगु medium change होगला there is a bending हालांकि अर्थ when a ray of light travels from rarer to denser medium refracted ray after refraction bends towards the normal means your angle of incidence is greater than angle of refraction I is greater than R ठीक अछि मन कर फास्ट मीडियम रे म कहि इंसिडेंट रे ता जो मीडियम रे फास्ट मीडियम कहबो refracted ray जो medium रे होता है second medium. Your first medium is denser medium, second medium is rarer medium. When a ray of light travels from denser to rarer medium, after refraction, refracted ray bends away from the normal. So here I is smaller than R. So angle of incidence is smaller than angle of refraction. Okay. If a ray of light strikes an interface normally, your angle of incidence is 0, angle of refraction will also be 0, and there is no deviation in the path of light. So in this case, there is no deviation. So question pacharibo in case of refraction, in which case there will be no deviation. Answer kon koiba when a ray of light strikes the interface or transparent medium or denser medium normally, angle of incidence will be 0, angle of refraction will be 0, and there will be no deviation in the path of the light. Path of light will never be deviated. ठीक আছে তাহলে এটা রেয়ার মিডিয়াম রা ডেনসর মিডিয়াম ডেনসর রেয়ার ডেনসর এই সব জিনিসরা কহিলি হলা কি which makes a medium denser which makes a medium rarer means মু তুমি কইছিলে যাহার রিফ্র্যাক্টিভ ইনডেক্স অধিক তো কইয়া ডেনসর যাহার রিফ্র্যাক্টিভ ইনডেক্স কম তা কইয়া রেয়ার কোন আমি এটি কম্পেয়ার করিবা ফার্স্ট আমি জিবা পূর্বরু লজ অফ রিফ্র্যাকশন জানিবা What are the laws of refraction? Just like laws of reflection, it is laws of refraction पढ़िबा कोन incident ray, refracted ray, normal to the interface at the point of incidence, all lie in the same plane. गोटिए समतल रहिबे refracted ray, incident ray, normal गोटिए plane रहिबे. That is the first law. Second, sign of angle of incidence by sign of angle of refraction, that means sin I by sin R is always a constant. That constant is called refractive index of the second medium with respect to first medium. It have second medium, you want to लिख देछि जो medium रे incident रे रहबो सेटा first medium कहबा, जो medium रे second refracted रे रहबो ता second medium कहबा. So sin I by sin R is equal to refractive index of second medium with respect to first medium. That will be identity. mu2 with respect to 1, or the refractive index of the second medium with respect to first medium equal to sin I by sin r. Mu2 with respect to 1 means refractive index of second medium with respect to first medium. अर्थात लाइट जो मीडियम जाउची हालांकि सेटा पर सेकंड मीडियम जो मीडियम रासु सेटा फर्स्ट मीडियम refractive index of the second medium with respect to first medium is equal to sin I by sin r. I refractive index विषय में डिस्कशन करिबे refractive index जो मीडियम जेते अधिक हो बेंडिंग से तो अधिक हो हालांकि mu2 with respect to mu1 and this formula is called Snell's law. ता कोन कहबा Snell's law. तो आमे सब पढेला को refractive index का प्रतिनिधित्व दरकार. So let us first discuss about refractive index. What is the refractive index of a medium? What is the refractive index of a medium? Remember, if refractive index of any medium is found out with respect to air, that is called its absolute refractive index. For example, glass or refractive index air को बाहर करना तब वह glass or absolute refractive index. Glass water और बाहर करना तब वह water absolute refractive index. কিন্তু গ্লাস ও ওয়াটার প্রতি বাহার করে সেটা absolute refractive index করিবা নাই যে কোন মিডিয়াম র refractive index বাহার করিয়া পাই air is chosen as the standard medium. Air or refractive index is 1. So to find out the refractive index of any medium with respect to air is called its absolute refractive index. তা কোন কইবা absolute refractive index. তো absolute refractive index র ডেফিনিশন আর পাবো absolute refractive index খালি লেখা হতে নি ওই লিখছি मु डायग्राम कर दोची मु जति करतम सकी देखो काम सब डायग्राम कर देची जति दरकार मु तुम सकी कहनी हला absolute refractive index of medium is defined as the ratio of speed of light in vacuum to speed of light in the given medium. মনে করো তুমি গ্লাস র absolute refractive index বার করছো তাহলে গ্লাস র absolute refractive index র ফর্মুলা কোন Now, refractive index of glass is equal to speed of light in air by speed of light in glass. মনে করো তুমি water absolute refractive index বার করছো তাহলে কোন কইবা refractive index of glass is equal to speed of light in air by speed of light in water. তো গোটে মিডিয়াম যদি এয়ার হই গলা তাকো আমি কইবা absolute refractive index. কোন কইবা absolute refractive index. ठीक है So what is the general definition of absolute refractive index? Absolute refractive index is defined as the ratio of speed of light or velocity of light in vacuum or air to speed or velocity of light in the given medium जो medium रो तुम्हें refractive index बाहर करछो. So refractive index of any medium with respect to air is called its absolute permittivity. Absolute permittivity तुम्हें 1 को लिखे रखा है simple mu लेखो काहेकि ना आरो मीडियम टा एब्सोल्यूट कहला माने नेक्स्ट मीडियम टा में आनी गेले या तो लिखा रखा है सो डायरेक्ट हुआ mu इक्वल टू c by v और कहबा mu इक्वल टू c by v ठीक अछि refractive index का डेफिनेशन दबा in terms of velocity in terms of wavelength मु नोट्स डाकी जेमती in terms of आगे लिखा है velocity in terms of wavelength absolute refractive index of a medium is defined as the ratio of velocity of light in air to velocity of light in the given medium. Velocity formula तब ऐसे wavelength. Refractive index of a medium is defined as the ratio of wavelength of light in air to wavelength of light in the given medium. ठीक अछि? हले लेखा पूरा देखिबो. तापर आसीबा relative refractive index. Refractive index of a medium with respect to another medium. For example, suppose two media are suppose medium 1, medium 2. What is the refractive index of the second medium with respect to first medium? I mean, refractive index of the second medium with respect to first medium is defined as the ratio of velocity of light in the first medium by velocity of light in the second medium. Manoila? Refractive index of second medium with respect to first medium is equal to velocity of light in first medium by velocity of light in the second medium. Similarly, in terms of wavelength, refractive index of second medium with respect to first medium is equal to wavelength of light in first medium by wavelength of light in second medium. refractive index of second medium with respect to first medium is equal to wavelength of light in first medium to wavelength of light in second medium. Okay, আমি ঠিক বুঝিয়ে সমস্তে ঠিক আছে। এটা আমি প্রুভ করিবি হলা refractive index of second medium with respect to first medium is equal to absolute refractive index किछि लेखुनी মানে absolute মনে রাখো refractive index of second medium with respect to first medium is equal to refractive index of the second medium by refractive index of the first medium. So mu 2 with respect to 1 equal to mu 2 by mu 1. Mu 2 with respect to 1 is equal to 1 by mu 1 with respect to 2. ठीक আছে, তা অর্থ তো বুঝো mu 2 by mu 1 equal 1 by mu 1 by mu 2. ঠিক আছে, মোটা প্রুফ করতে দেখাও। refractive index of second medium with respect to first medium or formula is called velocity of light in air to refractive index of second medium with respect to first medium or formula called velocity of light in first medium to velocity of light second medium. So mu 2 with respect to one formula like this v1 by v2 मोदी पर c हर देली ठीक अछि v1 by c by v2 by c ठीक अछि आमे रिपोर्ट प्ले mu equal to c by v. What is v by c पचला में कोई कोन जा 1 by mu v1 by c कोले लिखबा 1 by mu1 v2 by c लिखबा 1 by mu2 એટલે लिख देखो प्ले v1 by c c by v1 रो फॉर्मूला छु v1 तो v1 by c रो फॉर्मूला छु 1 by mu1 v2 by c रो फॉर्मूला छु 1 by mu2 तो सही दियो हेगला mu2 by mu1 तार पाई गेले refractive index of second medium with respect to first medium can also be expressed as mu2 by mu1. देखो बोला कि তাহলে এটি আমি জানিলে কোন প্লে ওই পট্টিকে দেখুছি mu2 by mu1 equal to v1 by v2 mu2 by mu1 is also equal lambda 1 by lambda 2 देखो mu1 lambda 1 mu2 lambda 2 তাহলে আমি জানলে how wavelength depends upon refractive index আমি কইবা wavelength is inversely proportional to refractive index. Wavelength is inversely proportional to refractive index. जो मीडियम रो refractive index जते बढ़िबो से मीडियम रे लाइट रो wavelength सेते कमिबो v1 mu1 or the velocity of light is also inversely proportional to refractive index. Refractive index of a medium increases, velocity of light decreases. So velocity is inversely proportional to what? Refractive index. Wavelength is also inversely proportional to refractive index means what the relation between velocity and wavelength पचारे velocity is directly proportional to wavelength. मोटी लिखी इसलिए देखो velocity is directly proportional to wavelength, but velocity is inversely proportional to refractive index. Wavelength is also inversely proportional to refractive index. ये तीन डाग भले देखो velocity is directly proportional to wavelength, velocity is inversely proportional to refractive index, wavelength is inversely proportional to refractive index. ठीक अछि हम एतरे देखते प्ले dispersion but a prism दे के light pass कर it splits into 7 constituent colors red r o y g b एरा सुनाइछो red और ब्लू कलर भितरे जदि पचरा हबो red और ब्लू कलर भितरे तार वेवलेंथ अधिक हम जाने प्ले red कलर वेवलेंथ अधिक हम ऑप्शन दे छि wavelength of red color is greater than wavelength of blue color. कहार wavelength दिटा भितर देखा ना red wavelength of red color is greater than wavelength of blue color. ठीक अछि wavelength सहित refractive index रे रिलेशन लिखिछि एठी देखा ता if wavelength of red color is greater than wavelength of blue color then refractive index for red color will be less than refractive index of the blue color. अथवा wavelength जदि पिले जार अधिका ता refractive index कम होबो जार कम ता refractive index अधिका ओके wavelength of red color is greater than wavelength of blue color तो red और blue color भितर कहारे refractive index अधिका पचाला ଆମେ କହିବା କାହାର ରେ blue color refractive index अधिका red color refractive index ର value होची कम ओके This one is your Snell's law. mu2 with respect to 1 jaha mu2 by mu1 would share. So refractive index of second medium with respect to first medium is equal to sine of angle of incidence to sine of angle of refraction. This is called Snell's law. So whenever a ray of light travels or passes from one medium to another medium, why there is a change in bending? Sorry, why there is a change in the path of light? Why there is a change in bending? Kahi bending hoji play. Why there is a change in the path of light? Light or path kahi change hoji. I am Snell's law apply kariba. As a first case. Last case दरकार नहीं है. First case करने के बाद देखो. Here light is traveling from rare rod to denser medium. Rare rod to denser medium. First medium is rare, second medium is denser. So whose refractive index is more? आखिर हम जो कहते हैं body denser लेखा तो तारी refractive index अधिका. So mu2 is greater than mu1. ठीक है जी? mu2 is greater than mu1. ताले mu2 is greater than mu1 means mu2 by mu1 will be greater than 1. अरे mu2 टा mu1 टू बड़ा होला माने mu2 by mu1 must be greater than 1. If mu2 by mu1 is greater than 1, then sin I by sin r is greater than 1. Means sin I is greater than sin r. Means I is greater than r. ताकि हम देखले I टा भी r से तो समान ही था. हमें कोई धन there is no bending, there is no change in path of light. तो हमें देखले कि angle of incidence is greater than angle of refraction. बुझिए आपने? So when a ray of light travels from rare to denser medium, there is a change in the path of light and angle of incidence is greater than angle of refraction. ठीक है? If a ray of light travels from denser to rarer medium, if a ray of light travels from denser to rarer medium, ठीक है? Your first medium is denser, second medium is rarer. Means our refractive index कम, our refractive index अधिका. ताले mu2 is less than mu1. mu2 by mu1 is less than 1. So mu2 by mu1 is less than 1. Sin I by sin r is less than 1. Means sin I is less than sin r, I is less than r. Again there is a change in the path of light and angle of incidence is smaller than angle of refraction. That's why we say when a ray of light travels from rarer to denser, it bends towards the normal. When a ray of light travels from denser to rarer, it bends away from the normal. Okay, these are the conclusion. এই ভিতরে আমি কম খোঁজ প্লেন. Whenever a ray of light travels from one medium to another medium, clear? जो point रखो जो point wise मानो. When a ray of light travels from one medium to another medium, there is a change in the path of light. Number one. Number two, there is no change in frequency of light. Light or frequency change होगा नहीं. There is no change in phase of light. Light or phase भी change होगा नहीं. हम वो mechanics से जानते हैं what is phase. There is no change in frequency. There is no change in phase. But what changes? Velocity of light changes. Wavelength of light changes. What determines to what extent velocity and wavelength will change? The physical quantity that determines the magnitude of change in velocity or magnitude of change in wavelength is called refractive index of the medium. Velocity of light is inversely proportional to refractive index. Wavelength of light is also inversely proportional to refractive index. Jete refractive index बढ़िबो velocity बढ़िबो velocity कमिबो. Jete refractive index बढ़िबो wavelength मध्य कमिबो. For example, where velocity of light will be more, in air or in glass? Glass or refractive index ta air to adhika. So velocity of light will be more in air and less in glass. Water or glass bhitere kaha refractive index ko adhika pe play? Water or refractive when a ray of light is traveling from water to glass. Orthati water ta rare medium, glass ta denser medium. Kahi ki na glass or refractive index ta water or refractive index tharu adhika. ठीक है. So when a ray of light travels from glass to water, so velocity of light in glass is smaller than velocity of light in what? Water. ठीक है. ये बुझाने समझते बुझले. There is a change in the path of light. There is no change in frequency. There is no change in phase. There is a change in velocity. There is a change in wavelength. I want a simple formula man रखते हैं. Velocity equal to frequency wavelength. V equal L lambda. Do you remember the formula? V equal to L lambda. Velocity equal to wavelength into frequency. One of the in case of refraction, there is no change in frequency of L is a constant. So V is directly proportional to lambda. Velocity of light is directly proportional to wavelength, and both are inversely proportional to refractive index. Confuse hobo nahi. Gote medium ro refractive index badhila mane velocity will decrease, wavelength will also decrease. Okay. Let us now discuss the principle of reversibility of light. Here we have the notes to the refractive index that is subheading principle of reversibility of light. What is principle of reversibility of light? Suppose there is a refracting medium. The refracting medium, what is a refracting medium? Which separates from rarer to denser. So this is called interface. O2 would a ray of light incident color. Suppose A point ray. OA is the incident ray. So I will direction A, B, suppose refracted ray. Refracted ray to normal quality, what a mirror pe A mirror pai, A refracted ray ta incident ray laki kaam kala. So here angle of incidence is 0. So angle of reflection will also be 0. So jo path ray aitha to same path ray bala. I will return to only data O. So this is called reversibility of principle of reversibility of light. So what is principle of reversibility of light? When a ray of light travels through different media, suffers a number of reflections and refractions, if it will be reversed in opposite direction, then it will follow the exact path. अर्थात जो पाथ रे से रिफ्लेक्शन रिफ्रैक्शन हेकी मिरर पाकु आसीथिबो सेही पाथ रे से पुनी इनिशियल पोजीशन को दिस इज कॉल्ड प्रिंसिपल ऑफ रिवर्सिबिलिटी ऑफ लाइट ओके तापर हम पढिया प्ले अपरेंट डेप्थ तापर काहे प्ले अपरेंट डेप्थ रियल डेप्थ नॉर्मल शिफ्ट ए तीन लाइन से पढिया हम डायग्राम कर देछि अपरेंट डेप्थ देखो आम कौन करिया गोटे ग्लास हम गोटे कंटेनर रखी कंटेनर किसी वाटर रखी वाटर रे तुम यूज करता हो 1 रुपी कॉइन रख ठीक अच्छी बास ठीक अच्छी वर्तमान कॉइन टा तुम पोजीशन देख केते तळे अछि कंटेनर केते तळे कॉइन अछि pour some water to the container वर्तमान कंटेनर किसी वाटर पोर कर मो ई पर्यंत वाटर पोर करछि देखियो पे तुम लागिबो कॉइन टा ऊपर उठी अछि कॉइन इज रेस्ट टू सम हाइट above the bottom of the beaker. Why? Due to refraction. Why? Due to refraction. अर्थात actual जो पोजीशन थिला ताको हम कहया रियल डेप्थ जो पोजीशन पड़ी आछि ता कहला अपरेंट डेप्थ हला सेही विषय में डिस्कशन करबी देखो ए रे मन रखले ए कंटेनर किछ वाटर अछि कंटेनर वाटर केते थिकनेस अछि के थिकनेस ओ जे ऑब्जेक्ट अछि एटा कॉइन भाबो बा जे कोनसी मटेरियल भाबो कारण O2 रे ऑफ लाइट आसीरी आम आखिरे पड़िले हम जाके ऑब्जेक्ट देखला जे कोन सिस्टम देखुचे द रे ऑफ लाइट मस्ट कम फ्रॉम दैट ऑब्जेक्ट तो ओ ऑब्जेक्ट रे वर्तमान ओ टी ऑब्जेक्ट अछि हला ठीक अछि मु दीटा रे इंसिडेंट रे एरिया ऑफ लाइट ओ इज इंसिडेंट नॉर्मली ऑन द वाटर सरफेस देखो प्ले ऊपरटा अछि एयर तलटा अछि वाटर हला A ray of light is incident at the point A normally. If incident normally, then angle of incidence is 0. So angle of refraction will also be 0. It will remain undeviated. Deviate होगा ना जो पाथ है से पाथ वाला. So here OA is the incident ray. AA dash is the refracted ray. OA is the incident ray. AA dash is the refracted ray. Your angle of incidence is 0 and angle of refraction is also equal to 0. Another ray of light OB is incident at the point B at an angle of incidence I to the number. Since your ray of light is traveling from water to air, means denser to rarer medium, it will bend away from the normal. So it bends away from the normal along BC. Hello? तो रिफ्लेक्शन कहले दीटा रिफ्लेक्टेड रे जो पॉइंट जाके मिसिबे दैट द पोजीशन ऑफ द इमेज एक्चुअली मिसिबे दैट द रियल इमेज appears to come from that point that is called virtual हला वर्तमान ए दीटा रिफ्लेक्टेड रे appears to दीटा को बैकवर्ड एक्सटेंशन कली these two refracted rays appear to come from the point I So I is appears to come means virtual image. So I is the virtual image object O. अर्थ आमे वाटर सरफेस देखिबा एठी ऑब्जेक्ट आछन देखिबा अर्थ दिस डेप्थ AI depth is called apparent depth पूरा A थारु O पर्यंत डेप्थ को रियल डेप्थ and that is taken as T. वर्तमान रिफ्रैक्टिव इंडेक्स रियल डेप्थ apparent depth भितर रिलेशन कोन पड़िबा ठीक अछि. Remember this is angle of incidence, this is normal, so this angle is equal to this angle. If this angle is high, this angle is also equal to high. Okay, again this is normal, so both are parallel. This is the this angle is equal to this angle. Why? Because this is the bisector. This angle is equal to this angle, corresponding angle no अनुरूप कोण. तले एटा R है, एटा R हेला, एटा I हेला, एटा I हेला. ठीक अछि. बर्तमान हम कोन करिबा बाहर करिबा OAB triangle plus OAB triangle sin I equal to P by H. A P कोटा AB, H कोटा OB. ताकि लिखिबी sin I equal to AB P by H. हां OB. ठीक अछि. In the triangle ABI, sin R equal to P by H. P कोन AB, H टा कोन BI. Sin R equal to AB by IA. Okay, AB by sorry. AB by IB. Sin R equal to P by H. ठीक है. Let us divide these two equations. So हम कौन पाई अपने sin I by sin R equal to AB by OB divided by AB by IB. By into लिख दो कौन IB by AB. AB cancel हो गया. That is equal to IB by OB. IB by OB. ठीक है. देखो. If these two refracted rays will enter our eye, then only we can see the position of the virtual image eye. So if these two refracted rays will enter our eye, definitely the point B must be very close to the point A. That means we can take IB is nearly equal to IA, OB is nearly equal to OA. Again we check. If these two refracted rays have to enter our eye, then point B must be very close to the point A. So actually possible nahi play because the size of our people. The point B must be very close to the point A. If point B is very close to the point A, then we can assume OB is nearly equal to OA. So OB is agar लिखि पारबा OA. IB is nearly equal to IA. IB जगह लिख परिबा में I अर्थ हमें वर्तमान लिख परिबा that is nearly equal to I जगह कोन लिख अपने IA OB जगह कोन लिख अपने OA. Okay, here light is traveling from denser medium to rarer medium. किंतु जो medium रे incident ray अछि ता first medium, जो medium रे refracted ray अछि second medium. है ना. Snell's law apply to the Snell's law कोन sin of angle of incidence to sin of angle of refraction is equal to refractive index of the second medium with respect to first medium. ताले हम कोन लिखबा mu AR का second medium with respect to water is equal to sin I by sin R. ठीक अछि. sin I by sin R हम बाहर कर दीजिए. कहते हैं IA by OA. ओके, तो जो प्लेन में होची खाता से मैच कर दियो. ओके, that implies mu A W equal to IA by OA. हम कहती प्ले mu2 with respect to 1 is equal to 1 by mu1 with respect to যেন ওয়াটারটা তলকু আনিবি ইয়াটা যদি উপরকু নেই যাবি তাহলে আর পটর ইকুয়ালিটি চেঞ্জ করবি তার তখন লিখি মিউ ডব্লিউ উইথ রেসপেক্ট টু এ ইকুয়াল টু ও এ বাই আই এ ঠিক আছে এটি রিফ্রাক্টিভ ইন্ডেক্স অফ ওয়াটার উইথ রেসপেক্ট টু এয়ার মিন্স याकू कहिबा वाटर रो एब्सोल्यूट रिफ्रैक्टिव इंडेक्स एब्सोल्यूट रिफ्रैक्टिव इंडेक्स का लिखिया दरकार है वाटर यार हला दैट इंप्लाइज mu equal to OA by IA एडी व्हाट इज mu is the absolute refractive index of water with respect to what person with respect to air लेवल देखिए चेक कर दो खाता से ओके that implies mu equal to OA टा को कहि रियल डेप्थ लिख दी रियल डेप्थ पूरा रियल डेप्थ लिख दी r डॉट d लिखुची IA टा को या अपरेंट डेप्थ लिख ले अपरेंट डेप्थ ताले रिफ्रैक्टिव इंडेक्स ऑफ a medium is equal to real depth by apparent depth so what is apparent depth so apparent depth is equal to real depth by mu that's the formula तणु जे कौन सी गोटे मीडियम रो रिफ्रैक्टिव इंडेक्स जानि दिबो ठीक अछि तणु रियल डेप्थ रिफ्रैक्टिव इंडेक्स हॉरिजॉन्टल बाय अपरेंट डेप्थ रियल डेप्थ डिवाइडेड बाय रिफ्रैक्टिव इंडेक्स ट्रांसफर अपरेंट डेप्थ ओके नेक्स्ट क्वेश्चन actual position of the object is O the position of the virtual image is I ठीक अछि so to what height it is raised that is equal to OI so in the denser medium the object appears to be raised by what height that height is called its normal shift or the normally say O to shift kori is kodi ki I ki so what is normal shift am pachara koiba normal shift equal to koda OI equal to OA minus IA देखो देखी OI equal OA minus IA ठीक अछि OA टा माने कोन कहिबा रियल डेप्थ माइनस IA टा कोन कहिबा अपरेंट डेप्थ रो फॉर्मूला लिखि रियल डेप्थ बाय u और रियल डेप्थ रे कोन छी एटी कोन OA तो लिखि OA बाय u ठीक अछि OA कमन आनरी 1 minus 1 by u that implies normal shift जेति माने ऊपर उठी गला पोजीशन ऑफ द ऑब्जेक्ट जदि तार सिंबल कमन मोशन देछि स्मॉल d बली स्मॉल d रखिबी सो स्मॉल d इक्वल टू OA is equal to thickness of water in the container तानबाटी d whole into 1 minus 1 by u so that is the formula for अर्थ हम दुटा फॉर्मूला ले ड्यू टू रिफ्रैक्शन in a denser medium object appears to raise to some height that means apparent depth is always smaller than real depth and what is apparent depth real depth divided by refractive index of the medium ठीक अछि what is the expression for normal shift ना normal shift रो सिंबल तो x नियो जहां जुनियो मुझे d नै छी d equal to thickness of the refractive medium whole into 1 minus 1 by mu stands for refractive index of the second of water with respect to air the glass with respect that means absolute refractive index of the medium okay मतलब